Hi there, welcome to the lab. Today we're going to have a look at what should be a Zoyi ZT-703S. It's a handheld multimeter oscilloscope unit combined. Supposedly that's what's in this package. I ordered this unit from AliExpress a few weeks ago, paid for it with my own funds. And so I'd just like to ask that if you found this video to be helpful, please give it a thumbs up and subscribe to the channel. Questions and comments are always welcome. The feedback is appreciated and it helps me figure out where to focus my activity. Now let's get in the package. So I have to say that most of the time the stuff that I'm ordering from AliExpress is well packaged. Once in a while it's not, but most of the time it is. So, outer wrap, and look at that. Somebody has gone to some good effort here, and they've put it all in bubble wrap. So a lot of bubble wrap. Where does it start? Somewhere here. Okay. So, just slice that open. And okay, what do we have here? Whoa. This unit that I ordered is with 2 probes. So I guess one probe must be in the box. And so here's the second probe. We'll have a look at the probe in a second. I just want to finish all the unboxing here. We can see it's an oscilloscope multimeter, 3-in-1, dual channel. It's got 25,000 counts. That must be on the multimeter side. 50 megahertz bandwidth on the oscilloscope side. And some details about single channel, dual channel. I'm not going to read through all of these details. All of that stuff is all available online. So here we have the package, and so here is another probe in the package. Like I said, I ordered a 2 probe unit. Then we have a case and the rest of the box. Get that out of the way. So if we unzip the case, we've got the oscilloscope multimeter. It's kind of a nice unit. Fits okay. We'll have a look at another oscilloscope multimeter maybe in a second for comparison. And then a set of probes for the multimeter side and a charging cord. So I guess that's nice. It doesn't use, it uses rechargeable batteries. So there's no battery compartment in there. So we'll just recharge that. Let's see what we can see here. Comment to make sure. So Zoyi seems to like these little comment stickers. It says, stop testing voltage in current mode. When you're in current mode, you don't really want to run voltage through there because you'll probably end up blowing the fuse. So that's a bad thing. So now this is a 25,000 count true RMS multimeter we can see there. And this unit actually, it has 3 features. It's a multimeter, it's an oscilloscope, and it also has a signal generator function. And I think the signal generator output and the charging point are over here. We'll find out all about those details. And it'll probably be a good idea for me to sort of plug that in to charge while we look at some of the other components. So let me just get a charge cable and hook this up. There's a user manual here, and to my pleasant surprise, the entire user manual, which is about 30 pages, is in English. Actually, it's a little over 30 pages, 35 pages. So a lot of information in terms of how to use all the various features, the multimeter, the oscilloscope, the signal generator. So all the features are described here. a set of multimeter probes. Not too surprising. So these are probably a little bit sharp. So those are gold plated. So that's nice because that means that we'll have good success when we're trying to make contact with the things that we're measuring. So I like that. Good set of gold plated probes. Now, of course, these are PVC, so no silicone happiness here, but that, you know, that's fine. They'll work just fine. And two probes, two oscilloscope probes. So in the little zippered bag here, you can tell that these things are a little more special than the multimeter probes. There's, I'll have to look in there. I'm not exactly sure what that is. So there's a bunch of colored rings. So these rings clip onto the probes here in order to allow us to differentiate between the channels when we're working on them. So a bunch of rings in a few different colors. I guess they've given us each color twice in case we break some. And I guess that's a little screwdriver. It's a very delicate little screwdriver. There's no electrical connection here. So I think that's a little screwdriver. Let's have a look at the probe and see why we might need a little screwdriver. So fairly typical oscilloscope probe. We've got our little grounding connection and the probe tip with a little hook that comes out, you can see there. And usually these pop off if you give them a pull, so you can get a bare tip there. Okay, but most of the time people are using them with these hooks on. Then we have here, we can switch the probe between a 1x mode, so that's 1x, and that's 10x. So if we're dealing with very small signals, we can amplify that signal. And that's it for that end. Now on this end, what does it say? It says it's a Y Pioneer P2060 voltage probe. So in 10x it's 60 megahertz, in 1x it's 6 megahertz, in 10x it's 10 megohms, in 1x it's 1 megohm. So that's just giving us some of the specifications. In 10x it'll do 300 volt Cat 2, and 1x it'll do 150 volt Cat 2. So it turns out, and this is learning for me, this is a trimmer for frequency compensation. And if we have a quick look at the instructions, it talks about how we can make sure that we've compensated properly for the square wave signal and the adjustment of the oscilloscope probe. And so we can see what an incorrect waves and some correct square waves here and what we should see. And so that trim pot and this little screwdriver are intended to allow us to make that sort of perform the tuning of the probe before we make use of it. And something else that I missed just shows that there can actually be some value in reading the manual. This is a locating sleeve. Just make sure the camera focuses up there. And so this is used, you can slide this onto the tip of the oscilloscope probe, and with this little notch here, it's meant to help you keep the probe from sliding around. So if you're trying to keep the probe steady, these two little flanges, if you will, on the edge, they'll keep the probe in place so it doesn't move around while you're looking at the oscilloscope display, as opposed to looking at where your probe tip is. So that's a handy thing to have. So I plugged it in, and one of the things to notice, and I'm not sure if it'll be apparent, but there's a little red light underneath the rel and what I guess is the power switch there. And so that's kind of an interesting thing. The good news is that this charges with a regular USB-C power delivery cable, which makes me quite happy. It comes with a USB-A to USB-C cable, which often makes me worried because some units don't have the ability to sort of do the power delivery negotiation, but this one does. And so that's really good news. So when the unit's fully charged, the red backlight on the power switch just goes off. So there's no green light to indicate it's fully charged. There's no indication on the display. This red LED just goes off when it's fully charged. The backlight there has gone out. And so that's how you know it's fully charged. And we're now ready to go to the next step, which is to power it up. So to turn it on, we just press the power button. Need to hold it a little. Logo, display, it powers up pretty quickly. It's not super bright there, so I need to figure out how to increase the brightness. As the unit ships, the default for the backlight is 30%. And so one of the things you might want to do is increase the backlight setting. And so we'll do that. Press the menu button, and then we go through the pages of the menu here. I'm not sure if you can see these pages at this point, but eventually we get a setting that allows us to change the backlight. I'm just going to bump that up to 100% so that it's nice and bright and that we can see everything. And then menu again, exits. Right now we're in oscilloscope mode, but the first set of tests we're going to do are going to be in multimeter mode. So that's here. We'll start with DC volts, and this is a reference source, and it's not on yet. The calibrated values are in the overlay. So this is 10 volts, and that's a little lower than expected. This is 7.5 volts. That's a very good reading for 7.5. This is 5 volts. That's a good reading. And 2.5 volts. Once again, another very good reading. So, very good performance for DC voltage. I don't have a reference source for DC millivolts, but I have found that my fingertips will generally be able to warm up a temperature thermocouple so that it gets to about 0.06 millivolts. So let's try that out. I've plugged in the thermocouple here, and my fingers, if they're warm enough, there we go, 60, 70, or yeah, 0.06, 0.07, 0.08. So seems to have good resolution there, although, like I say, I can't really tell you whether or not that's an accurate millivolt reading because I don't have a reference source there. Now we'll have a look at AC volts, and to switch into AC volts, we press the F1 button, and that'll switch us from DC volts where we are now. That switches us to AC volts. Now the power is not on yet, so we're seeing a little bit of ghost voltage. This unit doesn't have low impedance mode. I'll turn the power on, and since we have a full color display, it's turning red to show us that it's a high voltage and we should be cautious. I'll just do that one more time. So it takes a second or two, but reasonable enough, and shows us the voltage there. And it is also showing in the bottom right corner the frequency, 59.99 hertz, pretty close to 60, which is what we'd expect. Now we're going to look at resistance using this resistance reference source. And so we'll just go into resistance mode here. So I think that's resistance. Let's just check through. That's continuity, that's diode, that's capacitance, and so that's resistance. So starting from the top here, this is 10 ohms. Pretty good. This is 100 ohms. A little high. 1,000 ohms. It's getting a little high, but not too bad. 10K ohms. A little high again. And 100K. So once again, the readings are all a little high relative to the calibrated values. Now we'll look at capacitance. So this capacitance, the first capacitor here is 100 picofarads. So that's reading as about 70 picofarads, 0.072 nanofarads. So a lot of meters have trouble with this one. Then this is 1 nanofarad, a little low. 10 nanofarads, a little low. 100 nanofarads, a little low. 1,000 nanofarads, a little low. And 10 microfarads. So that one is pretty good, pretty typical. Now we'll look at diode check. It's diode check, and I've got a test box here. So that's reading good forward voltages, lighting up the diodes. But there are no sounds. And one of the things I'm generally looking for in the diode mode is to get a little bit of a short beep on the diodes and a continuity beep here on the short circuit. So it does show the correct values, but not providing the behavior that I would prefer to see. Now continuity, so let's get into continuity mode. There. And we'll just do the traditional probe tap. So pretty good. These are gold-plated probes. They tend to behave well. So pretty happy with that. That seems to work just fine. Now for DC amps, I've got a breadboard with a 5-volt supply, which I will turn on in a second, and 150 ohm resistor, and we can compute that we ought to get about 0.033 or 33 milliamps out of this circuit. So in the amp range, now that I've energized the circuit, we're seeing about 0.032 amps, which is what we would expect. The ideal would be 0.033. And then if we move over to the milliamp range, okay, we're seeing about 32 milliamps. Now, I think it's been observed in another review by another reviewer that if you're in the wrong mode, between the probes. So right now I'm in the milliamp probe location, but the amp range, it's not 3 amps. And if I put it into the amp location, but measure milliamps, I see an incorrect milliamp measurement. Overall, reasonably good performance for the measurement of DC amps. You just have to make sure that your probes match the setting for what you're measuring. Now we're going to look at some of the oscilloscope functions. To help out, initially at least, I've got a 10 kilohertz sine wave going in here just to give us something more interesting to look at than a flat line. So there are a few controls here. We can see that we're in run mode. We can see the storage window here on the frame. That's a fairly common approach used in a lot of oscilloscopes. We can see the vertical time per division, which is 50 microseconds per division. We can see the trigger level for channel 1, the battery indicator. We see the waveform, of course, in the main area. And we see that channel 1 is active. And we can also see that the vertical scale is 500 millivolts per division. This happens to be a 1 volt amplitude signal. And so that's 1 volt peak to peak. So from the bottom here of the sine wave to the top here of the sine wave, that's 1 volt in total. Everything right now makes sense, and this bottom indication has to do with the output of the signal generator, but we'll talk about that later. So for now, we'll just ignore this item. There are a few controls here, and so we can see that if we want to change it says vol, and I keep thinking volume, so that's actually volts. So if I want to change the volts or the time per division, that's on this, and that's selected by F1. And so I can change the voltage vertical scale, so that's now 1 volt per division. And so we can change that to change the frame of reference there. And we can also change the time basis here from, that's 25 microseconds, that's 100 microseconds. So that's sort of fairly common for oscilloscopes. Now, if I want to move this waveform, so if I want to adjust where the 0 point is, I can press F2, and then I can move the wave up or down. Now, a common thing that we might want to do is we might want to reset that to the 0 point, and so pressing F2 for a second or two will kind of re-zero the vertical scale. And then if we want to adjust the trigger point, which is indicated by this little green triangle, we press F3, and then we can adjust the trigger point. And of course, it works best if the trigger is somewhere in the signal that we're trying to work with, and that keeps it steady. You can see when I move the trigger point outside of the waveform begins to wander a little bit. So we'll just keep the trigger there, and I wonder if I hold that for a couple of seconds, it moves the trigger back to the close to the 0 point. It says 25 millivolts. And if I had the cursors on, this would help me adjust the cursors, but right now the cursors are off. Now there are a lot of other settings, and I'm not going to go through all of the settings because it would take a fairly long time. When I press menu, it turns on a lot of other things here. So this allows me to change which channel I'm controlling for all the settings. So the yellow is channel 1, that we can tell here. So this toggles between channel 1 and channel 2, and we'll stick with channel 1 for now. So you can see we can turn channels on and off, and that's why you can see for channel 2 I've turned off. If we go through these things, here's where we can change the coupling. The coupling can be AC or DC. This is a DC signal, so that's fine. And we can also change the probe here between a ×1 probe, a ×100 probe, and a ×10 probe. So this the probe is currently set to ×1. So in order for everything to line up, we'll just leave it at ×1. If we press this key again, we can change here. We can change the trigger mode to auto or normal or single. We'll just leave it at auto. Now, of course, it's frozen the waveform. I'll have to reset that. Then we can change the trigger to be the rising edge or the falling edge. That matters for certain kinds of analyses. And then the trigger source, whether the trigger is based on channel 1 or channel 2, but I've disabled channel 2. A few other settings, calibration, USB. So there's more settings here for the USB. So we don't want to do that. You can see not all of these things relate to the channel, so it can be a little bit confusing. We can change the language here. We can change the auto time off. We can change the backlight. This is where I made the backlight brighter. We can change the run mode to be normal, or there's a high frequency mode, which we'll be looking at in a minute, but the high frequency mode is more power intensive. So there's some recommendations at what frequency range to change the run mode, and we'll look at that in a few minutes. The version of the firmware is here. We can change the display to, we can either have the y-axis be time, which is fairly common, or we can have the y-axis be the input from channel 2, and that it's called XY. So channel 1 is the vertical and channel 2 is the horizontal, but we'll go back to time mode. The persistence of the signal, so min is the minimum, and then we can also turn on a fast Fourier transform of the signal, and we can adjust the time for the backlight. More apps, this is where we could turn on the signal generator. Cursors, this is where we turn on the cursors. Measure, we can turn on the measure modes. So we can have a variety of measurements that we turn on. Let's turn on the peak-to-peak voltage. That'll come in handy later on. And the frequency, then now we can see that I've got some measurements here. So the peak-to-peak voltage of this signal is showing. So that's what I expected, 1 volt. And as I said, this was a 10 kilohertz signal. And then output. This is another form of controlling the signal generator, although it's a little bit confusing. Okay. Kind of gone over most of the basic controls here. Now I want to look at how the 703S, which is a handheld oscilloscope, compares to a bench oscilloscope. In no way is the 703S going to be the equivalent of the bench oscilloscope. The bench oscilloscope is much more sophisticated. It's also much more expensive. But the thing that I'm sure you're probably wondering about is, okay, if I go with this sort of a handheld oscilloscope, and it has the advantages that it's easy to carry around, unlike the bench oscilloscope, but what am I giving up? Because that's the question. What am I giving up? How much accuracy am I losing? How much functionality am I losing when I do that? The bench oscilloscope has all kinds of controls because there's a lot more space. Now, a lot of those controls in the 703S are accessed through menus. And now I've got a signal generator, a function generator here. But let's go through a few different waveforms in the function generator, and we'll also increase the frequency. So I'm going to change the frequency here. Frequency. So let's dial the frequency up from kilohertz. This is now a 10 megahertz frequency. We can auto range both of these meters. So if I do that on the Regal, processes for a while, and then we get our signal here, and it kind of locks in, and eventually it tells us that this is a 10 megahertz signal, which is what we expect. I can do the same thing here on the Zoyi, and it's going to process for a while. And the Zoyi has a slightly different kind of performance. So whereas the Regal has moved the waveform so that it's centered on the origin, on the 0 line. And so once again, this is 1 volt peak to peak. And so it set the volt range here at 200 millivolts per division. The Zoyi takes a slightly different approach, and it moves the base of the waveform to the origin. And so we go from 0 up to 1 with a similar sort of 500 millivolt kind of range. I'm just going to adjust the scale here on the Regal to be 500 millivolts as well. Oops, there we go. 500 millivolts, and the vertical scale, or the horizontal scale. So the waveforms look kind of similar, but once again, it's still the same 10 megahertz signal going in here. Now the Zoyi is supposed to have a maximum frequency of 50 megahertz, and so I'm just going to start bumping up the frequency here. So that's 20 megahertz. We'll just change the vertical scale a little bit. There we go. And similarly here. So you can see that at 20 megahertz, there's a little more jitter in the display. Now, for the Zoyi, it says that we need to go, as the frequency increases, we need to go into high resolution mode. And I'm going to turn off channel 2. Now, after some adjusting, I've got a 10 megahertz signal, and so we can see that both of these units are agreeing. 10 megahertz here, 10 megahertz here. So this is 10 megahertz. This is 20 megahertz. So fairly stable. I just need to adjust the trigger here. Trigger. And so we'll keep the trigger in the middle just to keep the signal stable on the Zoyi. There's a little bit of noise up here on the 20 megahertz signal. I'm now going to go to 30 megahertz. I'm just going to bump that up a little bit so we can kind of see the signal, and that's starting to jitter quite a lot at 30 megahertz. 40 megahertz. The Zoyi is now having a hard time measuring the frequency, and I'm just going to go to 50 megahertz here, and very, very noisy on the Zoyi. And now we're going to go kind of to 60 megahertz, and that's beyond the range of the Zoyi. I'm just going to come back down here to 50 megahertz. We'll come down to 40. We'll do something that is a little more within the range. We'll go to 45 megahertz. So it's able to show us the signal. It's a little noisy, but you know, not kind of rock solid like the Regal, but for a handheld unit that's about 20% of the price, that's not bad. We can at least see the signal here. What I'd like to do is I'd like to start changing the waveform, and we'll see just how well the two units can handle the waveform. I mean, the Regal I don't think will have much trouble, but let's see how the Zoyi does. And I'm just going to increase the scale here on the Zoyi just to give us a little more to see. So let's go change the waveform. So there's a square wave, and as I said, this is 1 megahertz. So we can see a little bit of noise on the Regal. Now the Regal has a larger screen. That noise is also visible on the Zoyi. Let's go from square wave. This is a rectangle, not much difference. Trapezoid, not much difference. Here's a triangle wave. This is a ramp. Negative ramp. Stair trigger, and so we see more of a staircasing effect on the Regal. This is a stair step, negative stair. This is positive exponent, negative exponent, so in general, you can see that there's a teeny little bit of jitter on the Zoyi, but and a little more, the screen has a little more resolution. Let's see if we can kind of change the time signature here. Oops. So on the Zoyi, a little less sharpness than on the Regal, but we can still get a general picture of the waveform. And so unless we're concerned about some of these little, what I consider to be noise elements, or you can see the kind of the staircasing that is visible here is not quite as visible here. And the sharpness around some of the edge points just looks like a little bit of a curve here. So some of the fine details are not visible. So this, we can see let's see if the auto range helps. So the Zoyi can't quite keep up with this complex display. Random noise, ECG. Trapezoid signal. Sync pulse. So I'm not going to go through every single kind of signal that the signal generator can produce. But in general, I think you can see that within the scope of its operational range and with some of the limitations, the Zoyi does a really nice job for something that is, like I say, it is 20% of the price of this Regal scope. I want to show how waveforms are saved on the Zoyi and what that looks like. So right now the signal generator is outputting what it calls an ECG. We can see that here. And in order to save this waveform, I take the save button, I hold it down for a couple of seconds, and we can see that it generates a picture. Now I'm going to change the waveform. I don't want random noise. This is a trapezoid. Save this. And that generates another picture. Saved successfully. Now to review the images that I've saved, I need to go into the menu, and I need to go to More Apps here, and then Image View. And now I can see the two bitmaps here. And so I can press Enter there, and I can see it's done a screen capture essentially of the entire display there, and I can use the left and right arrow keys to go, that's the second image. And I go back to the first image. So you can see what it's capturing is it's capturing the entire display. So it's not actually capturing the waveform, it's doing a screen capture of the display. And then to get out of here, I can press these keys. You can see that I can use, I have access to the USB port, so I can use the USB port to send these over and look at these images on a computer and manipulate them. I can delete, I can format the internal memory, or I can exit, which is what I'll do now. And that takes me back to this screen. To go back to the oscilloscope mode, I press the mode button, and that takes me back here. Now I want to have a look at the capabilities of the signal generating feature on the Zoyi. So we're going to hook up to the signal generator and look at the signal on the Regal. The first thing to note is that in order to get into the signal generator, we need to go into the menu and go over a few screens here until we get more apps, and then we say enter. And we can either choose image view is for choosing to see and review saved waveforms. We can go to the signal generator here, enter, and so now we see the capability of the signal generator. We can see it's on. I haven't hooked up the Regal yet, and we can see that we've got not as many types of signal that we can generate as compared to the other generator here, but still, you know, a few basic waveforms that we can produce. Now, the connections for the signal generator here are on the side. The signal output is this top one, and the ground output is the bottom one, and that's labeled here. All right, so everything is connected and ranged, and we can see that the signal that's being output here is 1 kilohertz, so not a very aggressive signal. It's fairly steady on the Regal. I think the noise jitters might be the connectivity of the probe, just a little more sensitive. Although this says that it's a 2.5 volt peak to peak signal, the Regal doesn't really agree. It says it's more of a 2 volt signal. While I can increase the frequency, let's change that to 200 kilohertz even. So the Regal agrees, 200 kilohertz. That's pretty good. The voltage still not 2.5 volts. So that's a square wave. You can see that square wave looks kind of hideous at the top. Let's move this wire so you can see it better. Okay, so kind of a hideous looking square wave. Triangle wave, not too bad. A half wave, not very smooth at the top there. Full, and a sawtooth. Not the greatest, I would say, especially the square wave. The square wave is really super ugly. But you know, it kind of does work. Let's see how high the frequency can go here. So that's 344 kilohertz. I wonder why that is the limit. If you need to just get a bare signal out there, I guess that's okay. I don't think you'll be very happy with the square wave, but it is what it is. So it kind of works. So as I move through this, it keeps changing the frequency back to 100 kilohertz. So the triangle wave maxes out at 100 kilohertz. The square wave, that looks nothing like a square wave on the Regal, so don't use that for a square wave. And the sine wave, once again, it maxes out at 344 kilohertz. So very kind of weird behavior on the unit in that it really can't output this sort of consistent frequency as you change through the different waveforms. Quick look inside the unit. It is clearly meant to be opened up at some point because there are a couple of fuses here. It was a little trickier to open than usual because there are clips on the side here as well, but now that I know that, that won't be a problem. Interestingly enough, there are brass inserts, threaded inserts for the 4 main screws, which is a little unusual because usually it's just self-tapping screws into the plastic body. Interesting, there is a removable 18650 battery, so you know, not soldered in. That's kind of nice to have that being removable. And a couple of other things, and it'll take a little bit of time, but they've gone to a little bit of trouble to obscure some of the components that they've used here. So these 2 chips, they've had their identity somewhat erased, and the one down in this corner, the identity of this one is totally obscured. And then of course there's a large shielded area over here, so I'm not going to be able to get in there. But overall, fairly clean. Now we'll see if I can have a look at the other side of the board. And it is worth noting that the jacks here, these are sort of these screw-in posts on this side. So fairly solid construction with the jacks. 6 screws were holding the board down, and then the 4 On the jacks with all the screws out, the unit lifts out. Looking at the front of the unit, there's not a whole lot in this lower section. Behind the LCD screen, the LCD is attached with a ribbon cable. Behind the LCD screen is what I expect to be the main CPU for the unit. A little closer there. But there's been sort of a laser ablation removal of any information other than I can make out that it's a ST microelectronics. But aside from that, I would guess that's some sort of an ARM CPU or something like that. But no way to find out exactly what that is. So any sort of significant major component has had its identity erased. So we can't really tell what the makeup of the unit is. In summary, this is kind of a 3-in-1 unit. So you're buying this, you're getting 3 different kinds of devices all wrapped into one. Multimeter functionality seems to work just fine. Multimeter functionality has been pretty well established for a long time. No worries there with the multimeter functionality. The oscilloscope functionality within the parameters of specifications of the unit. The oscilloscope works reasonably well. Once again, it is about 20% of the price of a regular or let's say an entry-level bench oscilloscope, and yet it's in a small package. You can take this with you pretty much wherever you go. If you need an oscilloscope out in the field with you, this will do a fantastic job. The last part of this item is the function generator. I've got to say that the function generator, well, it works, but just barely. Doesn't really have a very high frequency range. The quality of the signals it's putting out is not so great. So if you need something that'll output a low frequency sine wave, then this will do it for you. But beyond that basic sine wave, the other kinds of signals that it puts out didn't appear to be all that great, and the frequency of those signals wouldn't really go very far. Not really the greatest performance in terms of the function generator on this unit. Overall, very nice unit that I would be very happy to use with those limitations kept in mind. If you found this video to be useful, please give it a thumbs up and subscribe to my channel. Thanks for watching, and until next time.